All right, my secondary math 2 class, we are going to be reviewing today. That means that next time is your test. Okay, so we are mostly talking about trigonometric functions. Okay, so basically we're working with a lot of triangles, a lot of right triangles. Okay, so for number 1, it's asking us to find the missing side of the triangle. Okay, so notice that it gives us 2 sides of the triangle and we are supposed to find the third. Well, when it gives us 2 sides, we have to use what's called the Pythagorean Theorem. Okay, and the Pythagorean Theorem states that a squared plus b squared equals c squared. Okay, and if you need to remind yourself what a, b, and c are, let's draw a little right triangle, right angle. So we know that c is always our hypotenuse. It's across from that right angle. Okay, and A and B can be either leg. So A, B, and C. Okay, so knowing this, let's look at number 1. So let's go ahead and label A, B, and C. So if C is always across from our right angle, across from our right angle, that means that 10 is my C. Okay, that means I can label X as A and B as 6. All right, well now that I know my A, B, and C, I can go ahead and plug it into my Pythagorean theorem and solve. So first, a squared, we labeled x as a, so x squared, plus b squared, my b is 6, so 6 squared, equals c squared, my c is 10, so 10 squared. Okay, so now in order to solve for x, let's do some simplifying, because we know what 6 squared, or 6 times 6, and 10 times 10 are. Okay, but we don't know what x is, so we can't simplify x. That one has to stay x squared. So we have x squared plus 6 squared. Well, what is 6 squared, or 6 times 6? We get 36. Okay, now I have 10 squared. What is 10 times 10? 100. Okay, so now looking at my side with my x, I need to get rid of this plus 36 first. So what is the opposite of plus 36? Or how do I get rid of plus 36? We are going to subtract 36. So I get x squared is equal to, what is 100 minus 36? I get 64. Okay, now to get x by itself, what is the opposite of square, or how do I get rid of square? We're going to square root. Okay, that cancels it out, leaving my x all by itself. Well, what is the square root of 64? What is the number that multiplies by itself to give me 64? Well, we know that 8 times 8 is 64, so the square root of 64 is 8. So we know that our missing side is 8. Okay, so whenever we get a nice pretty number, no decimals or square root symbols in it, okay, this is what's called a Pythagorean triple. 8, 6, 10 is a Pythagorean triple. They're all nice, pretty numbers. Okay, well, let's look at number 2, because this one might not be as nice. Okay, so we're going to solve it the exact same way. So let's label A, B, and C in number 2. Okay, so I know that C is always my hypotenuse, so 14 is C. I'm going to make A 9 and B X. Okay. Awesome, so now let's just plug it into our Pythagorean theorem. A squared, so 9 squared, plus b squared, x squared, equals c squared, 14 squared. Okay, so now let's go ahead and do some simplifying. So what is 9 squared? What is 9 times 9? We're going to get 81. Okay, x squared, we don't know x, so that just has to stay. X squared equals 14 squared. What is 14 times 14? I'm going to do it in my calculator. 14 squared, 196. Okay, so now I'm looking at my side with my x to get x by itself. So the first thing I got to get rid of is this positive 81. So how do I get rid of positive 81? Or what is the opposite of a positive 81? We are going to subtract 81 from both sides. Okay, so I have x squared left over. 196 minus 81 is going to give me 115. Okay, so now my last step, how do I get rid of squared? How do I get my x all by itself? What is the opposite of square? We have to square root. Okay, so that gives me my x all by itself. Okay, well, what is the square root of 115? I can't think of any number that multiplies by itself to give me 115, so we're going to go ahead and use our calculator. Second square root button down here, 115, and I get this big ugly decimal. So on your test, it might ask you for two things. Okay, if it wants what's called the exact answer, it wants you to leave it as a radical. Okay, so let's make that note. Exact answer. It wants it as a radical. Okay, but it might ask you for a decimal. So let's say it wants you to round to the nearest tenth. So that's this first spot. Okay, so we have to look at the number behind it. Since it's a 2, which is below 5, our 7 stays a 7. So our decimal ends up being 10.7. Okay, so this is our decimal answer. Okay, perfect. So that is solving for a missing side of a triangle when it gives us two sides already. Okay, well, we are going to now talk about trigonometry, which is going to allow us to solve for missing sides when we only are given one side and an angle. Okay, before we do that, we need to identify the trigonometric ratios. Okay, when it says ratio, that means a fraction. Okay, so before we start identifying, let's identify what fractions go with what functions. So we have sine. Okay, we know that opposite over hypotenuse goes with sine, or so. Then we have cosine. We know that adjacent over hypotenuse goes with cosine. And then we have tangent. Opposite over adjacent goes with tangent. Okay, so if you remember so, ka, toa, this will be pretty easy to memorize. Okay, so let's go back here. So for number 3, it wants us to find the sine of C. Okay, so if we're looking for sine of C, always look at the angle that it wants. Okay, sine of C is right there. Or its angle C is right there, excuse me. Okay, so now looking at angle C, we need to identify the opposite, the adjacent, and the hypotenuse sides, all three sides. Okay, well, the hypotenuse is really easy to identify because it's always right across from our right angle. Okay, so we know that 50 is our hypotenuse. Okay, well, adjacent means next to. The side that is next to the angle, it's touching the angle, is 40. So we know that 40 is our adjacent side. And then opposite, pretty self-explanatory. If we were to start in our angle and go to the opposite side, we know that 30 is our opposite side. Okay, well, using this, we can write the trigonometric ratio. So the ratio that goes with sine of C equals, let's look back up here, which one are we going to use with sine? S, so opposite over hypotenuse. Okay, so we have opposite, 30, over hypotenuse, 50. Okay, and the last thing we need to do is reduce this fraction. So I see that 30 and 50 both end in a 0. That means I can reduce them by 10, or just take away those zeros. Okay, divided by 10, that's what we're doing there. So our final answer is sine of C equals 3 over 5. Final answer. All right, so let's do it again for 4. So again, it wants us to look at angle C. Okay, angle C is right there. Okay, so now, just like we did on number 3, let's identify opposite, hypotenuse, and adjacent angles. So hypotenuse is always right across. So we have our hypotenuse. Then we have our opposite, opposite, and adjacent. Okay, now we just need to identify what two sides do we need with tangent. Okay, T for tangent. That means we have opposite over adjacent. Okay, so we're going to write this one as the tangent of C is equal to opposite, 28, over adjacent, 21. Okay, last thing we need to do is reduce it. These guys can both be divided by 7. So we get tangent of C is equal to 28 divided by 7 is 4. And 21 divided by 7 is 3. So we simply reduce that fraction. And there we go. Okay, so now on numbers 5 through 8, we are actually going to use those trigonometric ratios in order to help us solve for missing sides. So remember up here we were finding missing sides when given 2 sides. But on 5 through 8 we're given 1 side and an angle. Okay, so let's look at number 5. Okay, so what angle does it give us? It gives us 63. So based on 63, then we need to identify the opposite, adjacent, or hypotenuse. Which 2 sides are it giving us now? Okay, well I see that 11 is right next to 63, so that tells me adjacent. And then x is on the opposite side of 63, so opposite. Okay, now we know what 2 sides, we need to find which function we're using. So opposite and adjacent is going to tell us tangent. Okay, so we always set this up with tangent is always next to our degrees. So tangent of 63 equals opposite, x, over adjacent, 11. Okay, well now we're solving for x. So look at our side with our x. So there's one thing we have to do to get x by itself. We need to get rid of divide by 11. Well, what is the opposite of divide by 11? We are going to multiply by 11 to both sides. Okay, and this is where you're going to need a calculator because x is all by itself on this side, but we need the tangent button in our calculator. Okay, so this is 11 times tangent button of 63, and we get 21.58. I want 1 decimal, so the 8 is going to turn that 5 into a 6. So 21.6. And that was our missing side. Okay, so let's do it again for number 6. So what angle is it giving us? So it's giving us 38. Okay, so now what 2 sides? So I see that x is across from my right angle. That tells me automatically that's my hypotenuse. Okay, and 20 is on the opposite side of my angle, so opposite. Perfect. So what function are we now using with opposite and hypotenuse? It's going to be my s for sine. So we're going to set this up, sine with the angle, 38, equals opposite, 20, over hypotenuse, x. Okay, so look at our side with our x. So our x is on bottom. Well, we need to get the x off the bottom. So what is the opposite of divide by x? You're going to multiply by x. So now what I have is x times sine of 38 equals 20. And that's okay. Our x is on this side now, and that's okay. Because what is the opposite of times by sine of 38? We are going to simply divide by sine of 38. That cancels it out. Do the same thing to this side. So we have x is all by itself, and we just need to punch this into our calculator. So I have 20 divided by sine button of 38 equals 32.48. The 8 is going to turn that 4 into a 5, so 32.5. And there we go. There was our missing side. Okay, let's look at 7. What angle does it give us on number 7? So we have 31. Okay, so I see that 15 is across from that right angle, so we know that's automatically hypotenuse. And then x is on the opposite side from my angle, so opposite. So again, what function are we using with opposite and hypotenuse? Sine, okay? So we're going to set this up, sine of 31 equals opposite, x, over hypotenuse, 15. Okay, this is the nice ones because there's only one step to get my x by itself. What's the opposite of divide by 15? We're going to multiply by 15. So x is all by itself on this side. Just got to punch it into our calculator. 15 times sine of 31. I get 7.72. The 2 is below 5, so that 7 is going to stay the same. So our final answer is 7.7. Beautiful. Okay, last example, number 8. What angle does it give us? It gives us 41. Okay, now based on 41, I see that 13 again is across from my right angle. That tells me hypotenuse. Okay, but x is right next to 41. That tells me it's the adjacent side. Okay, so what function are we using with adjacent and hypotenuse, or a and h? Cosine. Okay, so we're going to set this up. Cosine of the angle 41 equals adjacent x over hypotenuse 13. Okay, let's look at our side with our x. One step to get x by itself. What is the opposite of divide by 13? We are going to multiply by 13 on both sides. So that gives me my x by itself. I just need to punch this into my calculator. So I get 13 times cosine button of 41 equals 9.81. The 1 is below 5, so that 8 is going to stay an 8. So our final answer is 9.8. And there we go. Okay, those are your notes for today. There is a review assignment that goes with it.